Hi guys, welcome to Deep Diver. In this video, we will discuss Goroutine, which is one of the reason why Golang is so popular. So let us build towards Goroutine step by step. So this is the Golang course folder and I have created already the folder 18 underscore Goroutine and inside that a file goroutine.go. Okay, so let us say we add a function called print numbers here. Okay, and here I just want to print from 0 to 9. Okay, so for I colon equals 0, I is less equal to 9, I plus plus, and let us print I, and after I will have a space, and at last let us also add a print line. Okay, let us add one more function, and in this function we want to print alphabets from A to Z. Okay, so I will name this function as print alphabets, and here we need to print A to Z. So I will have a loop which will run 26 times. Okay, and we can print the alphabet like this, %C. Okay, we will keep some space as well, and then we can pass it here A plus I. Okay, and at last we will just add new line. Okay, so this is done. Let us call this function one by one. So first we will call print numbers. Okay, and then we will call print alphabets. Now if I run this code, it should run successfully. Let us see what it prints. Go run goroutine.go. So it is printing from 0 to 9 and then A to Z as expected, right? But now what if I want these two functions, print numbers and print alphabets, to progress simultaneously? How can we do that? So that's where Goroutine comes into the picture. So if we have two Goroutines running, one for this function print numbers and one for this function print alphabets, those Goroutine can progress simultaneously. So how can we create a Goroutine? To create a Goroutine for this function print numbers, we just add the go keyword before that. Okay. Similarly, for creating Goroutine for this function, we just add a go keyword, and that converts print alphabets into a Goroutine as well. Okay. So now let us run this code. So if I run this code again, what we see here? Oh, you see here there is no output coming. Why this is happening? Because main is creating one Goroutine, this print numbers, and then it is creating this Goroutine print alphabets, but it is not waiting for this Goroutines print numbers and print alphabets to execute. And whenever this main completes its execution, the program terminates. Before fixing this, let us discuss one more concept. Okay, so let me add a line here, fmt.println, and what I want to print here is how many Goroutines are created. Okay, so to print that we can use runtime library, and from there we will use this function numGoroutine, which basically gives us the number of Goroutines executing. Okay, let me add a string here as well, number of Goroutine. Okay, if I run this code again, you see this is printing number of Goroutine is 3. Okay, ignore this for a while. It is output from these Goroutines getting executed, but for now we want to focus on this line. So you see number of Goroutines is 3, but how many Goroutines we have created? We have created only 2, right? One for this print numbers and one for this print alphabets. Then why it is printing 3? What if I tell you from the very first program we have been using a Goroutine? Okay, and that Goroutine is main. But we don't see any Go keyword associated with this main function. Why is that so? When the program starts Go runtime, do not call this function main as a function. Internally, it does something conceptually which is equivalent to Go main. Okay, so this main Go routine is not created by us, but it is created by the Go runtime internally. Okay, so that's why you see the number of Go routine getting printed here is 3. So every Go program start with at least one Go routine, which is the main Go routine. Okay. Now let us discuss how we can make sure we give time to other Go routines which we are creating here, print numbers and print alphabets, to execute. Okay. For now I will comment this. One way by which we can force this main Go routine to wait for the others Go routine, print numbers and print alphabets to execute by adding some sleep. Okay, so let us add some sleep here. We'll use time.sleep, and let us say we wait for 2 seconds here. Okay, so like this you can make sure that the main Go routine waits for other Go routines to finish. And let us add one more line here, empty.println main Go routine finished. Okay, so if I open my terminal and run this code again, if you see now here, the first all the output from the Go routine print alphabets, and then the output from the print numbers. Let us run this again. This time also same output. Let us run this again. Let us run this again. Let us run this again. So this time it is printing kind of interleaved output, right? First 0 1 is getting printed, okay, and then up to Z, and then 2 3 4 5 6 7 8 9. Okay, let us run it one more time. So this Go routine execution is so fast that one of the Go routine is getting executed at once, then only the other Go routine is being executed. Okay, so if you want the output in such a way that we see some output from this and then some output from this, then what we can do here is inside these loop, let us add some sleep as well. Okay, so time dot sleep, and here we wait for 2 milliseconds. Okay, time dot millisecond. Okay, and the same sleep we will add in this print alphabets as well. And now if I run this code, you will see the output which is much more interleaved. So if I run this code again, you see A, then 0 1, then BC, then 2, then D, then 3 4, like this. Okay, now let us look into the definition of Go routine. Okay, so Go routine is a lightweight thread managed by the Go runtime, not by the operating system directly. Okay, so I want to point out two things here. First is this Go routine is a lightweight thread, and this Go routine is managed by the Go runtime, not by the operating system. So Go routine is a lightweight thread. So lightweight thread means the resources required to create and run a Go routine is minimal compared to the traditional threads. Traditional threads are expensive because they require larger memory. Traditional threads requires memory in order of MBs, but this Go routine requires memory only in order of KBs. Okay. The creation and destruction of traditional threads is expensive, and also the context switching between the traditional threads is expensive as they are managed by the operating system directly. Okay. But as Go routines are managed by the Go runtime, The creation, destruction, and also the context switching between the Go routines are much cheaper. We will discuss these things in much more detail when we discuss how Go runtime manages, creates, and run the Go routines using the JMP model. For now, you can just remember that Go routine is a lightweight thread and it is managed by the Go runtime, not by the operating system. Okay. Now let us move forward and discuss one last thing. So here till now we have created two functions, print numbers and print alphabets, and we are creating Go routines from these two functions. Okay, but we can also create Go routines using anonymous function. Okay, so how we can do that? We can do that like this. First we will use obviously the Go keyword. Okay, and then we need to provide an anonymous function. So anonymous function does not have any name. So what we will do is we will just copy this function and paste it here, and as anonymous function does not have name, we will delete the function name and then we will call this function like this. Okay, so here we are creating this Go routine using anonymous function. Similarly we can do for this other function as well. Okay, so here we'll use the Go keyword, copy paste the function, get rid of the function name, and then we will call the function. Okay, so if I execute this code again, you will see similar output here. Okay, so you can see we have A getting printed, then 0 1, then B, then 2, then C, like this. Okay, so this was all about Go routine. See you in the next video.